Alright, hey guys, what's up? It's the Culture Detective here, investigating your favorite things, and today I'm going to do some physics, and I am going to do physics DSE 2019, except I've already done the multiple choice part, so instead I'm going to do the mock part, which is probably just as difficult, because physics is the actual worst out of physics, chemistry, and biology. So here we go, 33 questions. You will see me do it. Let's go. First question, an object P is placed in contact with another object Q. P has higher internal energy and higher temperature than Q. Which of the following is incorrect? Now, there's heat flow from P to Q. I think so. The internal energy of P decreases. Heat flow stops when the internal energy of the objects are equal. Actually, you know what? I'm gonna say A, because just because P has a higher internal energy, it doesn't mean it has a higher temperature than... No, wait, it does. It says so in the fucking question. Okay. So, P has higher internal energy and higher temperature than Q. See, it's already tough in the first question. You think it's simple, but actually it's confusing. Internal energy of P decreases. Internal energy of Q increases. Yeah, I don't think the heat flow will stop when the because internal energies can also depends on their mass, which means that if P is larger than Q, then the energy flow will stop when P is still larger than Q, when the internal energy of P is still larger than Q. Okay, question 2. The energy needed to raise the temperature of an object by object A by 1 degree Celsius is half of that needed for another object B. The mass of object A is twice of that of object B. Alright, so... MC delta T E. So, for object A, two is twice that of object B. Okay, so let's say M, right? And then C, and then 1. So E equals to MC. And then for the second one, we need 2 times the energy to raise half M and C, just to make it 1. Just to make it rise by 1. Which means... Okay, from here we know C equals to E over M. And okay, so this becomes for E MC. So C should be 4E to M, which is 4C. So the specific heat capacity of A to B should be 1 to 4, because yeah. Okay, that already took me 4 minutes. You have to be kidding me. Alright, the apparatus shown is used to find the specific latent heat of the vaporization of liquid. Oh, not another calculation question. I hate this. When the liquid boils, the reading of the balance is taken. After 200 seconds, the reading of the balance decreases by 0.02 kg. The power output of the heater is 150 watt. If 20% of the energy supplied is lost to the surroundings, Find the specific latent heat of vaporization of the liquid. God damn it. Alright, so 150 watt times 200 second. Alright, times 1 minus 20%, because only 80% is actually supplied, equals to 0.02, I think. And then the specific latent heat of vaporization. Right, so 150. What are the odds that the answer I got is neither of the four? That will be hilarious. But it's very likely that it's going to happen, because that's how life works. All right, so 1200000. So it's 1, 2, 3, 4, 5, 6. C. I got C. Hopefully I'm right. Hopefully I'm right. Next, two ideal gases X and Y are kept at the same pressure. Their volume temperature graphs are shown. Which of the following statements are correct? Two volume graphs have the same intercept on the temperature axis. What? This is I don't know. I really don't know. The ratio of volumes of X and Y. See, what? PV over T. So, so V over T is the slope. Yeah. And the slope is P. Then, is it? What the? Oh my God. What the? Ratio of volumes of X and Y is smaller at lower temperature. I guess so. No, wait, is it? Oh my God. They are at different slopes, yes, but the ratio is always similar. Is it? I'm going to say 2 is wrong. I think 2 is wrong. The number of moles of X larger than... Wait. PV equals to nRT. So... this is dependent on this thing. So... volume depends on this thing. So I guess 3 is right. Then by process of elimination, it's B. That already took me 8 minutes. Are you fucking kidding me? Peter runs from point A to point B of a running track below. What is his displacement from point A? Well, that's 100 meters. And this angle is 36.9 degrees from east to south. So if you flip it around, 53.1 degrees. So it's D. Yeah. All right. The velocity of a football changes with time t as shown. Which of the following graphs best represents how the displacement s of the football changes with time t? Fuck you. Okay, so at first it is velocity is lower than 0, so I guess it's going backwards. And then it stops, and then it moves, and then it accelerates forward again. So yeah, I think it's B. Oh no, wait, no, I think it's A. I think it's A, because the V sort of increases. So it's it's smooth. It's supposed to be smooth. Yeah. The velocity sort of it gets slower and slower to the opposite direction. I think it's A then. I think it's A. Very likely it's A. It does not get back to the original position. It gets back to the original position at this point. Right, because same mass. No, same size, same area, yeah? Alright. A girl is sitting on a wooden box which rests on a horizontal ground as shown. A constant force F is applied to the box so that the girl and the box move together with a common uniform speed. Which of the following statements are correct? The net force acting on the girl is non-zero. What is wrong? If it's not zero, then the girl will decelerate. The net force acting on the box is zero. That is true, because it's in a common uniform speed. Yeah. The girl tends to lean back when the force is withdrawn. What? I think so, because there's inertia. So I'm going with D. Or no, actually. If you keep pushing the box and you suddenly stop pushing the box, the girl should lean forward instead. So it's B. I think it's B. I don't know. I'm not sure. Alright. 8. A light rope is fixed at points A and B at the same horizontal level. A weight is hung at midpoint C of the rope. The rope depresses such ACB is 150 degrees. So this is a... Oh my god, I'm so sleepy. If the mass of the weight is 200 grams, what is the tension in the rope? 200 times 9.81 is the weight over 2. So, 981. And now 981 is the direct vertical, and it needs to be... What the fuck? Oh, 200 grams. I'm fucking stupid. So 0.2, right? Over 2, 0.981 per string. And that's the vertical. If I want to find the actual tension of the thing, I need to do this over cosine 75, I think. 3.7. Oh shit, it's not, it's neither of the four. It's fuck up. All right, ladies and gentlemen, I am back with with nothing. So okay, again, this thing is 0.2 times 9.81, which equals to 1.962 newtons. I broke my pen, my only pen. I love my life, actually. This thing, the tension of the rope, we don't actually have to divide it by 2, because this is the same rope, literally, meaning that the tension is like this and like this. So I don't think we actually need to divide it by 2. So this means that, or actually we can divide it by 2, but later on we're going to have to times 2 again. But if we divide it by 2, it's a little easier for us to calculate. So we have 75 degrees here. And okay, now I'm going to make it a little more simple for myself. This is 75 degrees. And this is 0.981. Fuck, did I really just break my pen? Did I really? Come on. Alright, 1 second. Okay, I tested my pen. It's not as broken now, but it's still kind of broken. So, you know. Oh, kill me. Alright. Let's go back to question 8 without breaking anything. 9.81 here. And in order to find this, because this thing over this thing equals to cosine 75. Or this thing over this thing equals to cosine 75. So this thing over cosine 75 equals 3.79, except it's not on every single option. That is why we need to we need to double it. Okay, what the? Yeah, I'm gonna go with D. Yeah. Alright, I need to use a different pen for tomorrow. And I don't want to use this one. This one is this one is insane, okay? This is too thick for me. Alright, I like this one. 0.5 millimeter head. Alright, question 9. 2 identical blocks A and B travel down 2 different smooth tracks as shown. Which of the following statements are correct? The potential energy lost, that is true. The speed of block A is the same as that of speed of block B when they reach the end. Do they have the same speed? Do they have the same speed? Yeah, I think so, yeah. See, I can't. I can't draw anything. This is going to be a problem, especially when I'm going to war. What the? Okay, I'm gonna keep going. Block A and B. Okay, that's wrong. 3 is wrong. I know that. I know that for a fact. It's A. Look at this mess that I've created. Question 10. A student pulls a block along a rough horizontal table as shown in the figure. A block moves at a constant velocity for 2 meters. What is the work done against friction? So the force is wait. Let me draw this real quick, 1 sec. So this is actually 8 cosine 30, which I personally believe is 6.9. Now, 6 cosine 30, but we also have the friction. Now, this thing, is the force. And force times 2 meters is 13.9 joules. So I believe it's C. Yeah. Question 11. 2 kg trolley moves at 6 meter per second, initially collides with a stationary trolley of mass 1 kg. Okay. What is the velocity of the trolleys? They stick together? Alright. This is easy. mv plus mv equals to mv. So, 2 times 6 plus 0 equals 2. V. So, 4 then. V is 4. I don't even need to calculate this. Yeah, 4. Alright, C. Number 12. The figure shows a door that is opened by pulling it. Which of the following statements are incorrect? When opening a door, a smaller force is required if we pull at a point far away from the hinge. That is correct. When opening a door, the direction of the pulling has no effect on the motion. That I think is wrong. Wait, so this is wrong. This is correct. That's why I need to cross it, because the question is asking what is incorrect. So this I don't think is correct. If the door turns at a constant speed, its acceleration is 0. I think it's wrong because it's circular, so I think it's wrong. So it's 2 and 3, it's another C. A bullet fired horizontally towards a vertical wall 1 meter away. It hits the wall at a point 0.5 meter below the point of projection. Okay, so this thing fires horizontally. Okay, so this thing is 1 meter away. Hits the wall at 1.5. What is the speed? Why? Alright. Horizontally. So vertically, it's at rest. So, okay. Think. It traveled 0.5. So S equals a UT plus 200 plus 1 over 2 AT squared. So 0.5 equals 0.5. 9.81 T squared. T equals to 0.5 over 0.5 is 1, of course, and then over 9.81, and then this thing, it's 0.319 seconds. And in 1 meter, okay, 3.13, it's a B. Alright. Next question. The acceleration due to gravity near the Earth's surface is G. A planet has the same mass as Earth and its radius is half of the Earth's radius. Okay, so G equals to GM over R square. So if the R is half, but the mass is the same, then it's just 1 over 4, right? Yeah, I think it's just 1 over 4G, or 1 over 4G. Oh no, it's 4. Because the radius. Yeah, it should. Yeah, because. Okay, I'm not gonna further question myself. Question 15. Which of the following about the uniform circular motion is correct? The magnitude of net force is constant. The magnitude of acceleration is constant. The speed of the moving object is constant. The velocity of the moving object is constant. Oh my goodness. I think the velocity is not constant because it just goes back to 0. I guess. I I guess. So I guess it's D. I'm not really sure. A ray of light travels through a glass block is shown. What is angle theta? This is theta, right? Alright, so if this 68 and this 60, then this is a 30 and this is a 22. Is that correct? Yep, I am correct. If this is 22, then this is 22 as well. Alright, then the one that comes out of it should be 30 as well. B. Yeah, hopefully I'm right. Hopefully I'm right. A longitudinal wave is traveling from left to right in a medium. Figure A shows the equilibrium positions of the particles A to L in the medium. Figure B shows the positions of the particles at a certain time t when the wave is passing through them. Shouldn't have broken the pen. There's still ink in it, and now it's a waste because I have to throw it away. Also, why did I buy this? I have 2 dumb pens now. I have 0. Alright. The following particles are vibrating in phase. A and D are not in phase. A and G are also not in phase because, yeah, D and G is not in phase. None of the above. It's D. See, I can't. See? I can't. This is annoying. This is incredibly annoying. This is so annoying, I swear. A straight water wave travels from region 1 to region 2 as shown above. Oh hey, we are finally halfway. We are already halfway. Alright, which of the following statements are correct? So if you look at here, right? Shoot. Okay. What am I even doing? If you look at here, yeah, it bends away from normal, meaning that it just got faster. So region 2 is faster, which means the wave speed is higher. Oh my god. Which means the wave speed is higher, which means the wavelength is also higher. I can't use this pen. Oh my god. This is insane. Region 1 is shallower than region 2. Okay, then region 2 is actually shallower then. So 1 is wrong. What the heck? The wavelength of the water waves in region 1 is shorter. That is correct because, yeah, frequency wrong. A. Alright, a train of straight water waves travel in a deep region. Shown, the waves pass through a small opening to a more shallow region. Okay, again, more shallow region means wave speed. Decrease wavelength. Decrease. And so if the wavelength decrease, it should be either C or D. And it's going to be C because that's not how diffraction looks like. Alright. A string is attached to a vibrator at the end, and is fixed on a wall. Is a certain frequency, stationary wave, in this instance shown, displacement, maxima. Which of the following statements are correct? The wavelength of the wave is 8 cm. Okay, so boom, boom, 20 divided to 8. Yep, that is correct. Particle X is momentarily at rest. No, wrong. It's actually the fastest one now. No wait. It's not. No wait. It's stationary. So yeah. Freaking X and particle X and particle Y have the same amplitude. Nope. So it's just Wade. What the? Okay. What the fuck is this? A stationary wave though. Stationary wave. Then they shouldn't have the same amplitude. If this is truly stationary, then this shouldn't be. They shouldn't have the same amplitude. So 3 is wrong. But then 2 is wrong too. If this is stationary. What the heck? I think I'm gonna go with I really don't know. It's either A or B, so I'm gonna write B or A, but I'm gonna choose B because yeah. The figure shows a displacement distance graph of stationary wave on a string. At the moment shown, point X is moving downwards. Which of the following statements are correct? Okay, this is also a stationary wave, right? At this moment, point Y is at rest. That is not true. That is not true. Point Z is a node. What the hell is a node? I'm gonna say it's a yes then. The displacements of point X and Y are always in the same direction. I think so. So I'm gonna go with C. The figure shows a Young's double slit experiment. Point P is a position on the screen, and the path difference at this port is 3 micrometer, and the light of wavelength 0.4 micrometer is used. What the heck? The 8th order dark fringe formed what? Wrong. No. What? No, because if it's dark, then it should be like a something 0.5, like an n.5. The fringe separation on the screen increases if a red light source is used. Okay, if the red light source is used, the lambda, aka the wavelength, probably decreases, right? If this decreased, then the fringe should also decrease, so B is wrong. What the? P becomes a bright fringe if the light of wavelength 0.5. Oh shit. I think 1 is right then. Because, oh my goodness. So by process of elimination, 1 and 3. Which of the following unit is different from the others? Joule is for energy, kilowatt hour is energy, mega electrovolt energy, watt is power. Easy. 2 insulated uncharged metal spheres X and Y are placed in contact, and another insulated uncharged metal sphere Z is put near them. Alright, what are the... what? Okay. Okay, this thing should be negatively charged, and this thing should be positively charged. And Z is put near them. So what the hell does Z have to do with anything? I'm gonna say 0 then. Z is 0. X is positive. Y is X is negative. Y is... I'm gonna go with B then. All right. A 1-volt battery is connected in series with a resistor. The voltage across the resistor is 1 volt. Which of the following statements is correct? When 0.5... okay. One volt, aggressive, 1 volt. Alright, 1 volt. When 0.5 of charge passes through the battery, 0.5 joule per charge. Yeah. Wait, so I think it's C. Yeah, flow through the resistor, 0.5 is okay. The circuit diagram shows 2 resistors and 3 emitters onto a power supply. If the total current of the power supply is 3 ampere, what is the voltage of the power supply? All right. So all right. So the average, the total resistance should be 10 ohm, because 15, 30 in parallel, they're 10. And with the, okay, that's the voltmeter. So 10 ohm, yeah, 10 ohm. P equals to I square R. Yeah. Oh, no. That is not the equation we're using. We're using V equals to IR, which equals to 3 times 10, which equals to 30. Is it 30? I still can't write anything. I can't write anything, I swear. Which of the following draws the largest current when operating at 200 volt? Largest current. So now this is what I'm doing. Okay. 100 volt, 0.5 ampere. Okay. Lamp with resistance of this thing, huh? Okay, that's 1. Oh. 200 over, that's also 1. 500, okay, then it should be D then, yeah? Alright. 3 wires, P, Q, and R from the connecting cable of an electric kettle are to be screwed to the pins X, Y, Z. Which of the following combination is correct? So R, okay, wait, ELN, right? ELN. So R to X. Yeah, obviously, again. So it's either C or D. And P should be to Y. So C, yeah. All right. Wires A, B, C, D carry the same current located at the corners of the square as shown in the figure. Point P is located at the center. What's the direction? Okay. So, okay, this thing. This thing. So this side. This thing. That side. This thing. This side. And this thing. That side. There should not be any magnetic fields then, because they're all canceled out each other. D. A rectangular conducting loop PQRS is placed near a long straight wire carrying current I as shown. If the loop moves to the left, oh my goodness, this thing. So it's this, the magnetic field. So now it needs to do this to oppose it. So now it's this, yeah. What are the directions of the induced current in the loop? Magnetic force. There's a magnetic force on PQ. What? This, no. The other hand. Current, like this. B right down here. So magnetic force that side. So to the left. So this is anti-clockwise, left. Yeah, A. Yeah, I'm gonna go with A. 3 more. Which of the following elements should not exist in the dynamo for direct current generation? That would be the split ring. That's easy. Which of the following statements describing the atomic structure of an atom is correct? The nucleus is positively charged. Yes. That's an atom. I don't know. What? Nucleus is unstable due to the repulsion among no, they don't repel. Okay. A. Help me. I can't write. Alright. I have 50 seconds to calculate the last question. Radioactive series is as shown below. What are the particles? Okay. Alpha, beta, D. And ladies and gentlemen, I got a 26 out of 33 for this paper, which is actually pretty great. But I have to admit, this is pretty easy. So now I am going to do this paper. So now I'm going to do the long questions paper. Hopefully there are only 9 questions. Are there only 9 questions? Oh god, there's 10. Okay. Cool. 10 questions. Here we go. Peter cooks an instant noodle with a microwave oven of power 1500 watt. He first adds the noodle and the soup powder into 0.5 kg of hot water. Before heating, the initial temperature is 60 degrees. Alright. Find the energy required to heat the bowl, noodle, and what the feek? What the feek? The whole thing? Alright. Nothing makes sense. Okay, nothing in this thing makes sense. That's a new zero. The bowl into initial temperature is already 60 degrees. Okay. So I guess, okay. What the? Okay, so I guess this is so weird. The heat capacity of soup powder can be neglected. What? Alright, so 90 times, okay, so let's say the bowl also gets to 100 degrees, so 100 minus 60 plus 170, the same thing, plus 0.5 kg of water, plus 4 this thing, plus this thing, and of course the water needs to evaporate, so 0.5 times this thing. Alright, well, that's a lot. That is indeed a lot. Alright. 900 times 40 plus 170 times 40 plus half times this thing times 40 is, wow, not much. 1256800. 1256800 joules, or 1256.8 kilojoules. 40% of the heat is lost to the surroundings during the heating and boiling processes. Find it. Oh my goodness. So P times T equals to energy, and okay, so E basically. So P what the fuck? It's already midnight right now. I want to slumber. Let me slumber. Alright, so P is 1,500 watts times T times 60% equals to 1256800. So T is 1256800. 1,396 seconds, or 23.3 minutes. Yeah. Alright. After the water reaches 100 degrees, it's allowed to boil for another 5 minutes. How much water is vaporized? Why? Alright. $100 times 5 times 60 times 60% equals to mass times 2.26 times. The mass should be um 8.37 kg. That doesn't even make any sense. What? How much? I think I'm already wrong here. Okay, I need to be more gentle with my pen because my pen is broken. My broken. Oh, there we go. This, okay, wait. Up. Alright. I'm gonna stick with this. If I'm wrong, I'm wrong. Whatever. If Peter Applies more water to the bowl before putting it into the oven. State without calculation, the change would be one's answer. More time is required, right? Will increase. Do I have to explain it? Nope, I just need to state it. Alright. Number 2. Amy has a cylindrical bowl with a lid shown in figure 2.1. The lid is a rigid disc which can seal the bowl tightly. The weight of the lid is 0.2 newtons. The air temperature and pressure in the room is 27 degrees Celsius and 101 kilopascal. Amy pours some warm soup into the bowl and then covers the bowl with the lid. The mouth of the bowl has a cross-sectional area of 0.02 meters square. A layer of oil floating on the soup prevents evaporation. The temperature of the soup and the air inside the bowl is 30 degrees when the lid is closed, and the air pressure inside at that moment is 101 kilopascal. After a certain time, the temperature inside the bowl drops to room temperature. Find the new air pressure. Okay, I know. I got this. Okay. Pressure. 101 kilopascal times... For fuck's sakes. What's wrong with me? What is wrong with me? Alright. Let's start all over again. P over T equals to P over T. 101 over 30 plus 273 to turn it into Kelvin. Room temperature, which is, I think I'm gonna, 27, yes. So this is 101 over 30 plus 20 times 27 plus 273, and that is 100. Very conveniently, very much explosion, yay. Alright, find the minimum force required to lift the lid. What? Find the 0.2, because 0. What? What? What the heck? Isn't... Oh, so I guess Newton per meter square equals a Pascal. So the weight of the lid is 0.2 newtons. And the cross-sectional area is this thing. So 0.2 over 0.02 is 410. I'm dumb. I am actually stupid. 10 Pascal? That doesn't make any sense. I'm wrong. I'm definitely wrong on this one. Alright, sometimes to equalize the pressure inside and outside of the bowl to ensure it's not forced to be in the or on the bowl, if that makes sense. Oh, minimum force required to lift the lid, like from the top. Maybe we need more than 0.2, but I don't know how do I calculate it. 100. Oh, maybe. Okay. 0.2 is the weight, but then we have the pressure itself, which is 100 kilopascal times 0.02. So 100 kilopascal times 0.02. This does not even make any sense. This is 2000.2 newtons. I don't know. Leave me alone. Question 3. A tennis player hits the tennis ball 2.5 meter above ground so that it flies off the racket with a velocity u and at an angle theta below the horizontal as shown. Take downward direction as positive. Air resistance is ignored. If u equals to 50 meters per second and theta equals to 30, calculate the landing speed. All right. Okay. So I need the time of flight first. Right, so S equals ut plus 1 over 2 at squared. S is 2.5 because 2.5 meters. This is 50. And sine 50 sine theta. Sine 30 degrees times t plus 1 over 2. Okay, I have a bad feeling about this. I do not like quadratic equations, but I'm gonna try because I am fucking insane. What the? See, this is why I dislike. There are two answers. What? Can I, I will use another method then. V squared equals to u squared plus 2as. V squared equals to 50 sine 30 degrees plus 2 negative this thing to 9.81 2.5. Maybe this is gonna work. So the original answer is 0.1 or 4.99. So we're gonna try to do this again. Plus 2.81. Okay, this is not working at all. Okay. This is not working at all. Nope, this is not working at all. So I'm gonna use this one again. Why? Both also work. I'm gonna go with 0.102 then. I feel like this one makes more sense. And then, can I do V equals to U plus AT with this thing A? $3.5. Why is nothing working? What the hell am I even doing right now? What the hell am I even doing? Okay, 0.102. Let's double check this, right? .6. Okay. Let's do 4.99 then. What the? Okay, so it's definitely 0.102 then. Then if this is the case, then I still can't use it. I don't understand. Why can't I use this one? Why can't I use this one? Oh, what? Now it's different. What the? What happened? 11.59. Okay, let's keep that in mind. V equals to U plus AT is T. 9.81. What the? So which one is which? This is why I fucking hate mechanics, by the way. I'm gonna go with the first one then. 11.6 meters per second. Yeah. So if it's V equals to U plus AT, then V minus U doesn't even make sense. Okay, I guess then I guess I'm gonna go with 24 then. Yeah, I'm gonna go with 24 meters per second. Then I guess this makes sense. V equals to U plus AT. So this thing minus 9.1 times 0.012, and I should get 25. Oh hey, look, now it's working. All right. Okay, so nothing's wrong. 24, that's the answer. That is the vertical speed. Now for the horizontal speed. Yeah. So yeah, the landing speed is 24 plus 50 cosine 30 degrees squared, I believe. 50 cosine 30 degrees. 43.3. Amazing. And then boom, 49.5. What the heck? It should not. It lost speed. It should gain. Okay, I have done something really wrong. Really wrong. It's 0.12, right? Oh, it shouldn't be negative then. It's 25, it's 26 then. It should be 26. So 26 plus this thing. Yeah. 50.5. What the heck? It's still weird, okay? It's still weird. Okay. I'm gonna go with 26. And now I'm gonna go with 50.5. This is so weird. If theta becomes 0, calculate the landing speed again. Alright, great stuff. I am amazed. I am happy. I love my life. Alright. If theta is 0, right, then S equals to UT plus this thing should be a 2.5 plus equals to this thing, t squared, and the t would be 5 times 2 over this thing, or actually no, because I need to, yep, there we go, 0.714. So it takes longer time, which makes a lot of sense. Now if I use this, then 0 plus 2, 2.5, 7. Alright, 7 meter per second. Yeah. So let's double check it. V equals to U plus AT. So again, this is 0.714 plus 981 plus, okay, hey, perfection, hey. All right, landing speed should be 7 plus 50 square, yeah, and it should be 50.5. I seriously think I'm doing something wrong. All right. If air resistance become very significant, compare the results of A and B in the new situation without calculation. Okay. If air resistance is very significant, then the speed should be lower. Then, wait. Both results should be lower because the air resistance decreases the speeds of both objects. Alright. If the tennis ball is replaced by a ping pong ball, ignoring the air resistance, compare the results of A and B without calculation. Okay, so a ping pong ball is definitely lighter. B should still be less than A. B should be less than A. And I need to explain it because the ping pong ball is lighter than a tennis ball. This doesn't feel like a physics paper to me for some reason. It just feels very, I don't know, feels very non-physics. If it's physics, it should be way more confusing than this, but you know what, whatever. I'll do this. A truck with the driver of total mass 4,000 kg. Okay. Travel with constant velocity of 20 to the left. It collided with a thick wall fixed to the ground. As shown in the figure, the truck was brought to a stop rapidly in 0.2 seconds. By considering the truck as a system, find out the net force on the truck before the collision and why was there a change in momentum on the truck during collision. So it collided. Alright. Net force on the truck. Net force? F equals to MA. It's not accelerating though. It's not accelerating. What's the net force? Where's the net force? Oh, I guess there's a friction. This is confusing. Did it crash? Did it not crash? It was brought to a stop, but did it crash? Net force, truck. What the fuck? Net force. I do not have a clue on this. I'm just gonna skip this. There is a change of momentum because the velocity is changed. Yeah? I don't know. Force of impact? Oh my goodness. This is tough. Okay. If accident happened on the moon, state any change for the answer. Shit. Shimata. Alright. Okay, so this thing is 4,000 times 9, 81. That's the friction. That's the driving force. Net force is 0. 0 newtons. It's moving in a constant velocity. It's 0. What? Alright. Force of impact though. Now that's not 0, because the driver is 80 kg, no, A1. And when he collides, there's the collision force. And force of impact. Huh. I guess I can say mv over t. Yeah, so mv mu over t. I can do that, I think. So 80 times 20 over 0.2. Eight thousand newtons. What? I really am not sure, by the way. Then wait a second. 40,000. I don't know, could be it. If accident happened on moon, answer should be smaller, because the weight of the driver is smaller. This is too straightforward. This question is too straightforward as a physics exam question. Okay, I just drew it on the top, but I'll do it again. Weight. Normal reaction. Friction. Driving force? I don't know. Alright. Next. Oh, it's not over. In fact, the accident happened on the Earth instead of the moon. The wall is replaced by a stationary car with a driver of total mass 1,000 kg, and after the collision, the truck sticks with the car. What the? Ah, shit. Yeah. So 4,000 times 20 plus, okay, there's no need because it's at rest, equals to V2, 4,000 plus 1,000. That's the conservation of momentum. Yeah. So 4,000 times this. 16 meters per second. Is the collision elastic? No, it is inelastic. It's stuck together. Wait a second. That's not what it means. Wrong. Yes, it is elastic. Yes. Wouldn't it be funny if I'm actually wrong? Without calculations, if both drivers are of the same mass, who should be more seriously hurt? That's a great question. I have no idea. So 800,000 joules of kinetic energy now turned to... Okay, so the kinetic energy is actually less now. What? Wait, then it's not elastic. Then it's... I'm confused. I'm confused. I'm going to say the car driver because it has the more dramatic change in kinetic energy. Yeah. State significance of the application. The seatbelt stops the drivers and passengers no, the seatbelt lowers their momentum to avoid letting them get hurt. Alright. Leo views a toy bird through a lens. The figure below shows what he observes. Okay, so it's upside down and it's smaller. So it's gotta be converging because it's convex. Sketch a ray diagram to show how the image is formed. Alright. And it's smaller too. So, okay, realistically, I will need a ruler for this, but I don't have much time now. So, yeah. Okay, so it's really smaller, so it's... And it's like this, yeah. No, wait, what the fuck? What the heck? What the heck? What the heck am I doing? Yeah, it should be like this. This is very ugly. But you know, it is what it is. Describe how the image observed changes as the toy bird moves closer. The image magnifies first. And then the image becomes blurry as it is formed at infinity. See another application of the lens. Magnifying glass. Oh, wait. Glasses for farsightedness. correcting glasses for farsightedness. In figure 5.1, state the change for the image if the lens is covered by half. The image is still formed, but darker, I guess. The image is more dim, I guess. Dimmer, yeah. Since only half the light rays are passed through. Alright, question 6. Alright, there we go. Question 6. A series of sound waves travel from water to air as shown in 6.1. Draw the refractive wave fronts in the figure. Refracted, so it's supposed to air, so it's faster now, so it's like this, yeah. And since it's faster, the wavelength should be a little longer as well. Yeah. Refracted light ray. All right. Oh no. Oh, it's sound. It's supposed to be slower then. Yeah. Okay. Main difference in traveling directions of the refracted ray in A and B. Travel slower in air. You know the drill, alright. State in which case A and B may result in total internal reflection in B. Describe what happens to the light and sound waves respectively if they pass through a gap of 0.2 meters in air. Nothing will happen. No observable change. For the sound waves, diffraction will occur. Yeah. Alright, this is pretty simple and straightforward, not gonna lie. Alright. Find the path difference at x. Well, 1 minus 0.5. No, actually 1.5 minus 1, 0.5 wavelengths. And then for y, it is 1.5 minus 1.5 equals 0 lambda. Find the path difference. Well, I already found it. From S1 and S2, hence state the type. Oh, okay. Destructive interference, disconstructive. What change will happen for the type of interference at X and Y respectively if the wavelength is halved? Great question. Nothing will happen. Wait, both Y will also be constructive, yeah? I think that's what happens. Without considering point B conditions, state the change of types of interference in part A answers if the sources are antiphase. What? This is very straightforward. Like, this is very not confusing. I should show you. Okay, I'm not doing it. Okay, fuck you. I'm not doing it. The electricity supply of an alternate account stated 0.02. I don't even need a calculator. Yeah. To which wire should have used live wire to ensure no current flows through, or more like no other components are live during a short circuit. Okay, this is so fucking easy. You know what? I'm just gonna stop here because this is too easy. Oh, there's a question 11. Are you kidding me? Oh my god. Okay, you know what? I'm just gonna stop here, and I need to go to bed. So yeah.